Welcome to our YouTube channel, Safety Guidelines, with loads of videos on different topics. I'm partner of Fahim Azam. The topic for this video is very interesting and informative. It is very special as it is related to machine guarding safety. Let's move on. Please do watch it thoroughly until the end to get benefits of this video. Introduction. Crushed hands and arms, severed fingers, blindness. The list of possible machinery-related injuries is as long as it is horrifying. Safeguards are essential for protecting workers from needless and preventable injuries. A good rule to remember is any machine part, function, or process which may cause injury must be safeguarded. Where the operation of a machine can injure the operator or other workers, the hazard must be controlled or eliminated. Causes of machine accidents: reaching in to clear equipment, not using lockout or tagout, unauthorized persons doing maintenance or using the machines, missing or loose machine guards. Where mechanical hazards occur: all parts of the machine which move while the machine is working can cause mechanical hazards. These can include reciprocating, rotating, and transverse moving parts, as well as feed mechanisms and auxiliary parts of the machine. Point of operation: that point where work is performed on the material, such as cutting, shaping, boring, or forming of stock, must be guarded. Rotating parts. Here are some of the examples of rotating parts of different machines. In-running nip points. In-running nip point hazards are caused by the rotating parts on machinery. There are three main types of in-running nips. Parts can rotate in opposite directions while their axes are parallel to each other. These parts may be in contact, producing a nip point, or in close proximity to each other where the stock fed between the rolls produces the nip points. This danger is common on machinery with intermeshing gears and rotating cylinders. Another type of nip point is created between rotating and tangentially moving parts, for example, a chain and a sprocket, a rack and pinion, or the point of contact between a power transmission belt and its pulley. Nip points can also occur between rotating and fixed parts, which create a shearing, crushing, or abrading action. For example, spooked hand wheels or flywheels, screw conveyors, or the periphery of an abrasive wheel and an incorrectly adjusted work rest. Requirements for safeguards. Prevent contact. A good safeguarding system eliminates the possibility of the operator or other workers placing parts of their bodies near hazardous moving parts. Number 2. Secure. A safeguard that can easily be made ineffective is no safeguard at all. Guards and safety devices should be made of durable material that will withstand the conditions of normal use and be firmly secured to the machine. Number 3. Protect from falling objects. A small tool which is dropped into a cycling machine could easily become a projectile that could strike and injure someone. Number 4. Create no new hazards. A safeguard defeats its own purpose if it creates a hazard of its own, such as a shear point, a jagged edge, or an unfinished surface which can cause a laceration. The edges of guards, for instance, should be rolled or bolted in such a way that they eliminate sharp edges. Number 5. Create new interference. Any safeguard which impedes a worker from performing a job quickly and comfortably might soon be overridden or disregarded. Proper safeguarding can actually enhance efficiency since it can relieve the worker's apprehensions about injury. Number 6. Allow safe lubrication. Locating oil reservoirs outside the guard with the line leading to the lubrication point will reduce the need for the worker to enter the hazardous area. Methods of machine safeguarding. There are 4 types of guards: fixed, interlocked, adjustable, and self-adjusting. And there are some examples for devices which include presence sensing, pullback, and restraint, as well as safety controls, tripwire cable, two-hand control, etc., and gates. A pullback device. It utilizes a series of cables attached to the operator's hands, wrist, or arms. Primarily used on machines with stroking action, it allows the access to the point of operation when the slide or ram is up. You can withdraw hands when the slide or ram begins to descend. The picture on the left explains the hands in die, which means as feeding. The point of operation is exposed, as well as the pullback device is attached and properly adjusted. The picture on the right explains that the die is closed. The hands have been withdrawn from the point of operation by a pullback device. Restraint device. Use cables or straps attached to the operator's hands and a fixed point. They must be adjusted to let the operator's hands travel within a predetermined safe area. Hand feeding tools are often necessary if the operation involves placing material into the danger area. Safety tripwire cables. Device located around the perimeter of or near the danger area. It is an operator must be able to reach the cable to stop the machine. A two-hand control. This kind of control requires a part revolution clutch, brake, and brake monitor if used on a power press as shown. A similar device known as a two-hand trip requires concurrent application of both of the operator's control buttons to activate the machine cycle, after which the hands are free. This device is used with machines equipped with full revolution clutches. The trips must be placed far enough from the point of operation to make it impossible for the operators to move their hands from the trip buttons or handles into the point of operation before the first half of the cycle is completed to prevent them from being accidentally placed in the danger area prior to the slide or ram or blade reaching the full down position. Gate. Another potential application of this type of device is where the gate is a component of a perimeter safeguarding system. Here, the gate may provide protection not only to the operator but to pedestrian traffic as well. The movable barrier device, which protects the operator at the point of operation before the machine cycle can be started. If the gate does not fully close, the machine will not function. Machine safety responsibilities. Management. Ensure that all the machinery is properly guarded. Supervisors. Train the employees on specific guard rules in their areas. Ensure machine guards remain in place and are functional. Immediately correct the machine guard deficiencies. Employees. Do not remove guards unless machine is locked and tagged. Report machine guard problems to supervisors immediately. Do not operate the equipment unless guards are in place. Training. Operators should receive training on the following. Number 1. hazards associated with particular machines. Number 2, how the safeguards provide protection and the hazards for which they are intended. Number 3, how and why to use the safeguards. Number 4, how and when safeguards can be removed and by whom. Number 5, what to do if a safeguard is damaged, missing, or unable to provide adequate protection. Summary. Safeguards are essential for protecting workers from needless and preventable machinery-related injuries. The point of operation, as well as all parts of the machine that move while the machine is working, must be safeguarded. A good rule to remember is any machine part, function, or process which may cause injury must be safeguarded. Thank you for watching this video. Our team is grateful towards the people who have already subscribed our channel. And those who haven't, please do remember to subscribe our channel. Press the bell icon to receive notifications regarding latest safety topics. Like, comment, and share our videos to encourage our team. Have a good time. See you in the next clip. Till then, goodbye.